Hello friends, welcome to our channel. Let's have a look at an earlier problem, that is problem 75, sort colors. This problem is very special because in the list given, there are three unique values, that is they are 0, 1, and 2. So this problem actually is the so-called Dutch national flag problem. So the method we're going to use is the so-called three partition. You can look at this Wikipedia page to look at the algorithm. Actually, the algorithm is related to Dexter, right? We all know Dexter's algorithm for shortest single source, shortest path. So in this video, our plan will be the following. So here, first I'm given a brute force solution. Solution. So the brute force solution actually is also important in this, because for some problems, actually, if you can solve it by brute force, it actually very demonstrate your ability. And then I'm going to look at one solution posted by a leetcode user. So we're going to use the three-way partition, right? So actually here, this algorithm it's very classic, but also very it's a clever algorithm. But now it's very classic. So we want to do things in place, right? So here one way is that we can do using rewrite, right? Rewrite. So we count the number of zeros, and ones, and twos, and then rewrite them. But for counting, so you can initialize three counting variables and then do a for loop over the numbers. That's one way. Or you can use a dictionary, right? So collections, counter, right? So nums. So this will give you the number zeros, number ones, and number twos. And then what he can do is for the following. So I'm going to write it with some redundancy. So for I in range, so let's see. Let's use D0 because the keys we are going to look at is 0, 1, 2. So for this one, so what we are going to do is nums I, so set to be 0. And then for I in range, so from D0 and to D0 plus D1. So this part, so this minus this number is D1. So therefore, D1 indices. So we are going to set them nums I to be 1. And then for I in range, say D0 plus D1, and then D0 plus D1 and plus D2. So here, if you look at this D0, D1, and D0, D1, and also D0, D1, D2, it involves a cumulative sum, right? You can also do in that way, just using one for block. So here I'm using 3 just to demonstrate you the details. So here you can set nums I, those i's to be 2. Then you can test, right? So I guess this way of doing the problem, though very fast, and actually it's not quite aligned in spirit to the problem. So now I'm going to look at the three partition algorithm. You can look at the Wikipedia. Also, you can look at one solution by this leetcode user. So it's called Dutch national flag algorithm. So basically, you set 3 pointers. So one is low, one is high, and one is mid. So you compare the mid value. So here is one example. So given this example, right? You initialize low and mid to be 0 and high to be the length minus 1, right? Then you compare the relation, right? So if the mid corresponding to a 0, so the 0 should be appending to the very left. So you are going to switch with the low and then increment both low and the mid by 1. So this is one case. Another case is that if your array mid is 1, so 1 should be in the middle, right? So in this case, what we do, we just increment the mid by 1. So this is the second case. The third case is that if the array mid is 2, So because 2 should appear in the third part. So we're going to switch with the number at mid, index mid and index high, and then we're going to shrink high by 1, right? So this is the so-called 3 partition. Here, let's look at the code. So this is a good demonstration by figure. So I'm going to so use this one as version v1, and then I'm going to do the 3 partition, bunch, national flag, no problem. So 3 v partition. So the thing is that first let me get the length. So let me change this nums to be capital A, just for convenience of writing. So what I'm going to do is set low equals mid equals 0, and high equals n-1. So notice that here I'm initializing 3 variables, but if you want, you can write like this. This is maybe more clear, right? So then, well, mid is less than or equal to high. What I'm going to do, I'm going to check mid. If a mid equals 0, right? So then I'm going to switch a mid with a low. It's going to be a low and a mid. And then in this case, once we do the switch, so meaning that the first element is set. We don't need to consider the first index corresponding to low. So we are going to do low increment by 1, similarly mid increment by 1. So this is the one case. Another case is a mid equals 2, the other end. So we should switch this with respect to high. So we have a mid, a high, and then to be a high and a mid, right? And then we are the last index, or the corresponding to high, we don't need to consider it anymore. So we're going to high decrement by 1. Other case, mid corresponding to 1, meaning that this position is set. I just increment this mid by 1. So this way, it will reset the A. So you can print it out just to test that. Let me first test for all cases and then do some print. Yeah, it passes all the cases. So now let's look at this example 1, maybe print. So we run. Yeah, after you do the algorithm and do the change in place, you get the correct output. Similarly for example 2, right? You have 0, 1, 2. So with that said, I guess that's it for the current problem. So I hope that this will interest you to the 3 partition method or even trick now. So with that said, that's it for the current video. Thank you.